Hello and welcome to our video on trigonometry in 3 dimensions. Now when we've got problems in 3 dimensions or 3D, I'll just write that up here. You'll get a shape, a 3-dimensional shape. This one here is a square-based pyramid and another square-based pyramid, but you could get all kinds of different, you might get a cube or a rectangular prism. What you need to do from the shape that you're given is try and visualize the right angle triangles. So a lot of this unit is about visualizing things and then putting them into place to work out how to work through the problem. So I've put here you could use the triangles that you visualize to help calculate unknown sides. So we're looking for right angle triangles in the shape. So we can use our SOH CAH TOA and what we know about right angle triangles. In this example here, you can see with the dotted lines, I'm going to go through a few of the right angle triangles. This one's probably pretty clear to you, standing out. You've got ones along the base, so the right angle is in the middle here. You've got this one on the back, standing up with the upright, going straight. And you can see various other ones as well. I might add this one in. And again, the right angle will be in the middle here. This diagram shows you clearly that first orange one that I highlighted here. They've just coloured it and taken it out, so you can clearly see that it works as a right angle triangle. Even though when you look at the diagram here, this doesn't look like a right angle, we know that an upright compared to a line that goes along the base will always make a right angle. So you can draw this triangle and use it to work out unknown sides that you need to find. In our example here, it says viewing points A and B, here they are, orient yourself with the picture, are at a horizontal distance from a clock tower, looks like Big Ben to me, of 36 metres and 28 metres respectively. So we can add those in, 36 metres for A and 28 metres for B. Okay, not... The question is, oh no, it also adds the viewing angle to the clock face at point B is 64. So point B is here, and we've got 64 degrees. They've already labelled it. I just put a little tick there so we can see it clearly. The question, part A, is asking us to find the height of the clock face above the viewing level to 3 decimal places. Okay. Height of the clock face above viewing level. We're trying to find this height here. And we've got an angle on this side, so I'm going to use this triangle on this side here. You can see the right angles are drawn in there for us already, but we would know that it would be a right angle between a straight up and a straight along the ground. So I'm going to redraw this right-hand triangle over here with its right angle, and we can label 64 here. This one is 28 metres and this one is the one we're trying to find. Second step is to label the sides. Hypotenuse, this one's opposite, this one's adjacent. Third step is to decide which ratio we're going to use. We've got opposite and adjacent, so I'm going to use tan. Substitute the values in. Opposite x over adjacent 28. Tan 64 equals x. Put that in the calculator. And you get x equals 57 point 57.41 meters, because this was in meters to start with. Section B is asking us to find the viewing angle to the clock face at point A to 2 decimal places. So from point A, we're looking for the viewing angle. I'll label that on here, and we can label that with a theta because it's an unknown quantity. So we'll need to redraw this left-hand triangle. I'm going to do that down here. With a right angle in it, because we know it's got a right angle. This length is 36 meters. This angle is theta, and we've already worked out the height to the clock face in our previous example, and that's 57.41 meters. Okay, first step, label the sides. Opposite, hypotenuse, adjacent. Second step, work out which ratio you're going to use. We've got O and A, so we can use tan theta equals O opposite over adjacent. Substitute the values in. Theta stays. Opposite is 57.41 over 36. And we'll need to do inverse tan of 57.41 over 36. If you put that into your calculator, you will end up with 46.85, and this time it's an angle, so it's in degrees. Thanks for watching the video today.